Now, this particular function that we just talked about raises an important question. We have some function, and it's a piecewise function, and it's curious because to the left of 3, the function is equal to x, y equals x, and to the right of 3, the function is equal to 0. And we found that the left-sided limit, as x approaches 3 from the left, of that function is 3. And we also found that the limit as x approaches 3 from the right-hand side, well, that was, oops, I don't know why I did that, that was 0. So this is troublesome. The limits don't match up. And when that happens, when the left-sided limit does not match up with the right-sided limit, the overall limit is said to not exist. So we can say this. The limit of this function, f of x, as x approaches 3, does not exist. D is D and E. And the reason why is because the left-sided limit, the limit as x approaches 3 from the left, does not equal the limit as x approaches 3 from the right. This overall limit, okay, can only exist when the left matches the right. When the left does not match the right, we have a D and E problem. We have a does not exist, and that's what we had in this case. If you remember the graph, let me pull that up. The graph over here obviously shows that there's a problem. There's a huge disconnect right there. When we get to talking about discontinuities, we'll talk about this particular one. But this function is going up to here, this function is going over here, so obviously there's a problem. And graphically, this side looks like I'm trending over here, and from this side, it looks like I'm trending over there. Those arrows clearly don't match up, so the overall limit doesn't exist because the left-sided limit points to something, and the right-sided limit points to something completely different.